Newton's method. Newton's method is used to approximate the zeros of a function, and it's especially useful for functions beyond x cubed. Now below is Newton's method, and x to the n plus 1 is just a subscript in terms of the term that you're working with. And x to the n represents a term, and you're going to substitute that value into the f function, so into the original, divided by the derivative of the function, placing that x value inside. So in this lesson, I'm going to show you a few examples, a few different situations using Newton's method. So the first example is when you're given x1. So you're given a certain value. So we want to find the third approximation for this equation, x cubed plus 3x minus 2. So I have the function x cubed plus 3x minus 2, and taking the derivative of that, it equals 3x squared plus 3. Now using Newton's method, I have the first term. The first term equals 1, so I need to find x2. And if I'm using Newton's method, x2 equals 1 minus, and I'm going to place 1 into the original equation. So 1 cubed plus 3 minus 2 equals 2. And if I place 1, which was the value of x1, into the derivative, I have 3 times 1 squared, which is 3. 3 plus 3 equals 6 on the bottom. So you can see that for the second term, I have 1 minus 2 over 6. And when I find common denominator, 6 over 6 minus 2 over 6 equals 4 over 6, which reduces to 2/3. So my second term equals 2/3. So in order to find the third approximation, the third root x cubed, I'm going to substitute 2/3 into Newton's method. Into the original function, f of x, and then in the denominator, the derivative, I also substitute in 2/3. And I'm going to use my graphing calculator for this. Some calculators you may be able to calculate it, but you'll use either your fraction button, your a over b button, and substitute it in, use your cubed button, and solve, and you'll get a long decimal answer, but it says to 6 decimal places, and so my value is 0.598291. So what I'd like you to do is just pause the video, and by substituting 2/3 into Newton's formula, see if you get the same value as I did. In this next situation, I give you an interval where the approximate root for the equation is between 1 and 2. So it's greater than 1 but less than 2. And I have an x to the 4th graph, x to the 4th minus x cubed plus 2x minus 6. And I want to try and find the root to 5 decimal places. So I'm just going to start with a guess for the interval. So in between 1 and 2, I'm going to guess 1.5. And I'm going to use Newton's method 4 or 5 times to see if I kind of get a pattern in terms of what the root could be. So x1 will equal 1.5. And now with Newton's method, in order to find x2, I sub it into Newton's formula. I'll have 1.5 minus, substitute 1.5 into f of x, divided by 1.5 into the derivative. And I complete my calculation using my calculator. So x2 is 1.65. x3, I substitute now 1.65 into Newton's formula. And do the same with x4 into Newton's formula. And the correct root that I get is 1.63102. Now, if you have a graphing calculator, a TI or a Casio or a Sharp calculator, then you can find out how to do it with your calculator. Each calculator does it differently, but you can use the answer button, and you just get the answer button and plug it into f of x, which substitutes into the answer to the fourth power minus the answer cubed plus 2 times the answer minus 6. And it's a little bit hard to describe here on the video, but in class, if your teacher can probably show you in class how you would use your particular calculator to solve using Newton's method. This one here, we have multiple roots. So in order to solve this, I know that I have a parabola. And if I have multiple roots, that means that this parabola must cross the x-axis in 2 places. So I'm going to work with the equation. And if I separate the equation, x squared equals 6x minus 2, I'll have a parabola going through 0, 0, and a line with y-intercept of -2 and a slope of 6. So it will cross that parabola, and I'm going to guess that the potential roots for the original are at 1 and 5. So I'll be using Newton's method in this question twice. I'm going to start off with x equals 1. So that's my first term. And my derivative of x squared minus 6x plus 2, my derivative is f prime of x would be 2x minus 6. Now, since I have f of x and f prime of x, I'll use Newton's method. So for x1, you can see on the left, I substitute 1 to find the second term, second possible root, and we're going to get closer and closer as we substitute down. I get 0.354 is where this parabola crosses the x-axis. And if I substitute 5 for the first term into Newton's method, I get the approximate root of 5.64575. So I'd like you to try this using your calculator, using Newton's method, and seeing if you get the same decimal values that I get. And as I mentioned earlier, you can use the answer key to just repeat the answer. So you're not typing out this 5 decimal number. You just use the answer key on your calculator into f of x and into the derivative, and that calculates it easily for you. And some calculators you can press second function entry and enter, and it will just calculate x2, x3, x4, x5, all one after another, but each calculator works differently. In this question, I'm approximating the root, the value of the cube root of 40 to 5 decimal places. Well, I do know that the cube root of 8 equals 2, cube root of 27 equals 3, and the cube root of 64 equals 4. So 40 is in between there, and I need to approximate it to 5 decimal places. Now, if I was to guess, I would say that the cube root of 40 is around 3.4 because it doesn't seem like it's quite halfway. But if I have to approximate it to 5 decimal places, that's where it gets more difficult, and that's where I need to use Newton's method. So to solve this, I have the cube root of 40. I'm going to make it equal x. 40 to the 1/3 equals x. And how do I get rid of the 1/3, the exponent 1/3? I'm going to cube both sides, because what I do to one side, I do to the other, and I'm allowed to do that. And since I cube both sides, 3 divided by 3, I'll just get the number 40, because the fraction times the whole number 3 equal 1. So 40 equals x cubed. I have f of x equals x cubed minus 40. And solving for the derivative, it will equal 3x squared. So since I kind of have my approximate root around 3 to 3.4, I'm going to use my first term equaling 3, and I substitute it into Newton's method. So 3 minus, plug in 3 into the original equation of f of x, and 3 into the derivative. Use your calculator when you're solving this. You can use your fraction button, you can plug it in right away. 3 cubed minus 40 divided by 3 times 3 squared. Your calculator will all solve it for you, and you get a value of 3.48148. You're either going to plug in this whole number into your calculator, into Newton's method again, or you'll use the answer key. And as I mentioned, some calculators you can just press second function entry, enter, and it will calculate x, the third term, the fourth term, and the fifth approximation. And you can see how the fourth term and the fifth term are similar. So now you know that you've found the cube root of 40 to 5 decimal places. You've calculated it.